My name is Siobhan Kavanagh. I'm Communications and Engagement Specialist with the Signpost Programme, and I'm chair for this first session, which is called Climate Challenges in Agriculture. Our first paper this morning is Weather Trends over the last 60 years, and it's been presented by Mary Curley of Met Éireann. Mary joined Met Éireann in 1996. She has worked in the Climate Services Division since 2002. Her areas of expertise include quality control, homogenisation, data analysis and data rescue. Mary was the project leader for producing the most recent 30-year climate averages, which is much of the data that will be presented today. So over to you, Mary, for this morning's session.
Good morning, everybody. I'm going to start today just by explaining the difference between weather and climate. So weather is what we experience day to day. So if we look at a forecast here, we can see that today, it's a few weeks, it's not actually today, but on the date when we looked at it, that it was the first day today is partially cloudy. It says tomorrow once again will be cloudy, then we can expect light rain Wednesday, Thursday we'll have sunny spells. But climate is the long-term average of the weather. And typically we measure climate over 30-year periods. And this is what I'm going to be talking to you about today. So what are climate 30-year averages? They're the mean of monthly, seasonal or annual values of climatological data, which may be means or totals, for example, a temperature mean or a total amount of rainfall over a 30-year period. And examples for the 30-year periods be 1961 to 1990 or 1991 to 2020. And we calculate these for a range of climate variables, including temperature, precipitation, sunshine, wind, atmospheric pressure, and other elements as well, such as days with fog, hail, thunder, etc. The WMO mandate that we calculate these 30-year averages every 10 year, where the last year of the period ends in a zero. So that's why you'll see 1991 to 2020, which is what I'll be mainly talking about today. The elements I'll be talking about will be temperature, precipitation, and sunshine. So why do we calculate the climate averages? Well, for a start, they're a baseline for the weather at a particular location and time. So you'll hear us saying that the weather in Donegal was above or below average. And this is what we use as a baseline. So what these climate averages do, they're comparing that day's weather to these, or the month's weather to what we'd expect over the previous 30 years. So we can also use them to tell us what weather we might expect at a particular location. So if somebody's going on holidays, you may have used them yourself. Say you're going to Spain in June and you want to see what the weather's like, or over the summertime, what the temperatures are, how they change, whether it's going to be wet or dry in a particular area of a country. And also farmers can use them then for what the weather will be like in what the climate will be like in their area over the particular months or years. They're also a data set for climate mapping. So the maps you'll see, a lot of them will be produced from our periods and also for modelling. So when we model the climate into the future, what we do is we compare it to the previous, say, a 30-year period. So we use them to verify the model. So you'll actually model back in time to that period and see if it'll match up. And it's also a baseline where you might start off the model. And we can also use them then to track the changing climate. So the differences between two 30-year average periods. So today I'll be telling you about the differences we've seen between the 1961 to 1990 period and the most recent period, 1991 to 2020. So how do we produce them? Well, across Ireland we have weather stations. We have our synoptic network, which up till the early 2000s, we got data every hour, but now we get data in every minute since they've been automated. And then we've had a volunteer network across the country which give us either climate, which will have a range of elements such as temperature and some sunshine, or then we have station and rainfall, and then there's other ones which just have rainfall. The reason we have more rainfall station is that rainfall is very, very variable across the country, and we need these extra stations to accurately show what the rainfall is across the country. So what we do when we get the data is we quality control it, and then we do a thing called homogenization. Now, in previous periods, we didn't do homogenization, homogenization is basically when we're looking at the climate, we want any changes to be due to only a change in climate, not because the station moved or because we used a different thermometer, etc. So we use statistical techniques to try and pick up those changes along with information on the station when there were changes made. And we use those to homogenize the data. Not every station can be homogenized. You need at least 15 years of data. And whilst we have a lot of stations around the country, not every station is going to have data for 30 years or more. We actually did this procedure over the full 60 years so that we would be able to compare the two different periods with using a comparable data set. And then we infill missing data. So some of the stations, when we homogenize them, will have a full 60 years of data, for example, Dublin Airport, but other ones like Mount Dillon, one of our stations, for example, it's only a new station since the early 2000s and it wouldn't have the full year of data. So we'd infill the data and then we calculate 30-year averages for each of these locations. And once we've done this, we grid the data. So we use interpolation methods to produce maps like this. Here's an example of one for rainfall. In this map, you can see that we don't show the data for Northern Ireland. We actually do use the data and we put it through this process to calculate the data for Ireland, but Northern Ireland come out under the UK Met Office, so they calculate this separately themselves. So the results that we got from this study so far. So for looking first at air temperature, and we're looking at mean temperature, which we calculate from the max and the min of each day divided by 2. It's just, you see it down there on the corner of my slide, how we calculate it. And first of all, just looking at the annual mean temperature, we found that it ranged now in the 1991 to 2020 period from approximately 8.5 to 10.8 degrees Celsius. Now you will see little patches on the map, little grey patches here, where it's below that, and they're more areas of high areas up in mountainous regions. So, but basically where most of us live, it'll be 8.5 to 10.8 degrees. And then what we do is we produce this map on a 1 kilometre grid, and then we take all those grid points and average them to get an average value for the island of Ireland, for Ireland without Northern Ireland. So when we do that calculation, we find that the annual mean temperature in the 1991 to 2020 period is 9.8 degrees Celsius. And then, as I say, we create a map like this for 1961 to 1990, and we subtract the two and we see what the differences is. And when we compare the two maps, we find that we've had an increase of approximately 0.7 of a degree for Ireland. And looking at this map and the scale here, you can see that every region of Ireland saw this increase. We also looked at the seasonal mean temperature for the period, and as you might expect, summer is the warmest with a mean temperature of 14.6 degrees Celsius, and that differs from the previous 30-year period by plus 0.7 of a degree Celsius. Autumn is the next highest with a mean temperature of 10.3 degrees Celsius, which is a 0.7 degrees Celsius increase as well on the previous period, then followed by spring, which has a mean temperature of 8.8 degrees Celsius, which showed an increase of 0.8 of a degree Celsius. And as we'd all expect, winter is still the coldest with a mean temperature of 5.4 degrees Celsius. And that was an increase of 0.6 degrees on the previous period. Then we look at the mean monthly air temperature. We can see that the coldest month is January, followed closely by February and December. As you might expect, the summer months are the warmest, with July being the warmest month, closely followed by August and then June. And then when we compare it with the previous 30-year period, well, what do we see? So whilst we do see an increase, it does vary from month to month. We see the highest increases between the two periods of 0.9, and we see that in February, April, May, and November. But then if we look at October and December, the increase is much smaller. It's only a 0.2 degrees Celsius increase for October and 0.3 for December. So then just looking over the whole period. So this map here is called an anomaly map. So it's basically where we take each year's annual mean temperature for Ireland and we subtract it from the 1961 to 1990 period. For research, we tend to use, in meteorology, we use the 1961 to 1990 period for research. So using that period, you can see that the temperature has increased. The blue bars below the line means it's where the temperature is lower than average, the 61 to 90 average. And when it's the red ones are bars are where it's above average. And you can see that in the most recent period, apart from 2010 when we had the really cold period at the end of the year, every other year we've seen an increase in temperature, but it's not. It varies. Not all the years have the same increase, and we can see here in this period up to 2020, approximately 2007 was the highest year, but other years, whilst it is higher, it's not. It's not a consistent increase. And if we look at this then and we plot a trend through it, we find that on a decadal basis that we've seen an increase of 0.22 degrees per decade. And this is significant when we look at it with using Mann-Kendall test. Then if we look at the mean monthly anomalies, just to show you these ones, you can see how variable it is from year to year. And whilst it is very variable, we do see an increase in the trend in all years except for October. And you can see here October, it is a very variable month, like that there's some months are above and below average. And in fact, the last 3 years of the period were below average. Now, I didn't show you we also calculated the 30-year averages for the maximum and minimum air temperature. Unfortunately, with the time limit on the presentation, I can't show it to you, but it's just interesting to see how the decadal changes vary for max and min temperature. And just looking at annual, you can see you don't really see much difference. It's a very slight less change with the min temperature than the max. But then if we look at each season, we can see that we're actually in seeing the biggest increase in the minimum temperature comes in the summertime, whereas the maximum temperature, it's in the spring and the winter. So it's interesting to look at it in more detail like that. And you can see once again, the max temperature, the biggest increase in it per day, it's seen in February actually, whereas for minimum temperature, it's in August. So then just looking at the 30-year average annual rainfall for Ireland. So in the period 1991 to 2020, the rainfall for Ireland is about 1,290 millimetres. And it ranges from about 880 in regions along the east coast to over 2,040 in mountainous regions in the southwest and west of Ireland. And then when we compare it with the previous period, we find that overall for Ireland, we see an increase of approximately 7%. And the biggest increase we see are in the west and north of the country, but we see either no change or an increase in all areas. We don't see any areas decreasing. Then looking at the average seasonal rainfall, as you might expect, we have the highest rainfall in winter, followed by autumn, then summer, and the driest season is in the spring. But then just comparing it with the 1961 to 1990 period, we see a bit more detail on it. So whilst we see an overall increase of 7% on an annual scale, the biggest season we see an increase in is summer, excuse me, with an increase of plus 14%. And you can see here that every county has seen an increase or just slight increase, but it's across the board. But the biggest increases are actually on the south coast. Winter is the next highest increase in rainfall with a plus 7%. But once again, we can see differences across Ireland. And they're very interesting because we're actually seeing a decrease in rainfall in the east and southeast coast of Ireland, whereas we see more of an increase in the west and northwest of the country. And then in this autumn and spring, we can see it kind of changes. So in spring, we're seeing that the decrease, whilst there's an overall increase of 4%, there's actually less rainfall in the more recent period in the east and southeast of the country compared to an increase in the west of the country, whereas we see the opposite in autumn, where the rainfall has actually decreased slightly in autumn and increased in the south east of the country. And then just looking at the average monthly rainfall, we can see that May is the driest month, closely followed by April and June. The highest rainfall is in December with 142 millimetres, and that similarly we also have high rainfall in November and January. And then once again, just looking at the differences between the 1991 and 2020 period with 1961 to 1990, we see that the highest increase, we have a big increase of 28% rainfall in July. And when we look at the map here, we can see that it's either most places have had an increase in rainfall, no place has got a decrease. And we also get an increase in the mid to high teens in April, July, and April, June, and November. May doesn't change at all, and January and August there's very little change, but we see a decrease in rainfall in March and September. September having the lowest at -6 degrees, and we can see here most areas in September do decrease. But it just shows you across the country that whilst we can talk about rainfall increasing or decreasing as the country as a whole, there's a lot of variability across the country with what's happening. So then just looking at anomaly plots again, where we compare each year with the 1961 to 1990 average, you can see that once again rainfall is very variable. But on an annual basis, we see that there's an increase of 29 millimetres per decade, roughly, we're seeing. And this is significant with Mann-Kendall test. So then just looking at monthly rainfall anomalies, we can see how variable the rain is across the country. So example, looking at January, you can see that some years we've got high rainfall, other years it's below average rainfall. So, and you can see this across the board. So rainfall is very variable. We don't see any significant trend in rainfall on a monthly scale or a seasonal scale. Then just looking at sunshine. So sunshine, we don't have as many locations that cover the entire period. So you see, if you're looking at this map, you'll say, why don't they have any sunshine recordings in the Midlands? We actually do, but they don't cover the whole 30-year period. So when the next 30-year periods are produced in 10 years, well, less than 10 years time, almost 10 years time, we will have stations in the Midlands of the country as well. So we just felt that we didn't have enough stations to do a gridded map of the country. So on the background of this map, we've just used the satellite to give an idea of what would be like for the 30-year period across the country. And we can see here that the sunniest parts of the country are on the east and the south of the country. And in fact, Sherkin Island has the highest sunshine on an annual scale, whereas Ballyshannon in Donegal has the lowest sunshine amount on an annual scale. But overall, based on the 12 countries, the 12 stations, we have approximately just over 1,400 hours of sunshine a year. And we can see here over to the right in the top graph that May is the sunniest month, followed by June and then April. As you might expect, January and December have the most days with least no sunshine. And then just if we look at sunshine across the entire period, so the stations here are stations where we have sunshine hours across the entire 1961 to 2020 period. And if we look at these stations, we find that on an annual basis that between the two periods that we've seen an increase of 4.5% sunshine. And just looking at the graph itself, we can see here that in 1971 to 2000 that we actually saw a dip in sunshine, and then we see it starting to increase again. And it also sounds strange that we might say that it's got warmer, it's got wetter, and whilst it's got wetter, we've got more sunshine. But the reason for this is, and they've seen this across the globe, it's that air quality has improved. So it's a bit of a good news story in the sense that the reason that we're seeing more sunshine is there's less particulates in the air to reflect the sunlight, so more of it is reaching the surface. So it's due to the better quality of air that we're actually seeing this increase. So in conclusion, the period 1991 to 2020 was warmer, wetter and sunnier than the previous 1961 to 1990 period. So, but what can we expect in the future? Well, in Met Éireann, we've had a collaboration with UCC, the Murray Institution, UCG and the Irish Centre for High-End Computing. And we've collaborated to produce standardised national climate projections for Ireland and also to produce climate services to allow stakeholders to mitigate and adapt to climate change. But what do we expect? So just looking briefly, this here shows what we can expect on the left-hand side for temperature and in the summer and winter. And on the right-hand side, it shows the changes in rainfall. Now, if you look at the top of each map, you'll see a temperature change. So when they do the models for the climate projections, they look at the different emission scenarios from if we have zero carbon up to looking at what we're doing or increasing the amount of carbon we're releasing into the atmosphere. But rather than using that, which is a bit confusing for the general public, we look to see this figure here, which will tell you if we have a global temperature increase of 1.5 to 2.5, 3 or 4 degrees, what will we see for Ireland? And when we look at summer and winter temperature across all maps, we can see that the temperature will increase. It's not going to be the same. It'll be a little bit lower. And if you look at our translate pages, you can see the actual amounts, but it won't be as big as the global temperature, but we do see an increase. When we look at rainfall, it's a little bit different. So when we look at 1.5 or 2 degrees, you can see that some areas appear to get slightly wetter, whilst other areas appear to get drier. But as we get warmer, we go to 2.5, 3, 4 or 4 degrees, we can see that the summer rainfall the summers are getting drier. In the case of winter, across the board, we see that the winters are getting wetter. So they're the changes we expect to see. So if you want to learn more about the 30-year averages or the Translate project, you can find them on our website here. Thank you very much for listening.
Thank you very much, Mary. I think that was excellent and a very good sum up of
I can't hear you, Siobhan.
Sorry, Mary. Thanks very much for that. That's been a really good sum up of where we've come over the last 60 years in terms of climate. Just one or two questions for you, Mary, before we finish up. How do these results compare to international studies looking at climate change over the last 60 years? I presume there's comparable studies internationally.
Yeah, no, I may not have said it. When we produce these 30-year averages, every country in the world produces them all the Met services produce them for the WMO. And the most detail we know of is we look at them all and everybody is seeing these increases. But we particularly compare to the UK and Northern Ireland and we're seeing the exact same, figures across the globe as well, where we're seeing these increases.
Okay, and just a specific question there on the rainfall amount. So rainfall on average is increasing by 7%, but there seems to be a good bit of regional variation in that, with a lot more in the west, say in comparison to east or the southeast. Why is that the case?
Yeah, and it varies from, as you can see, like some months we get more in the west than we do in the southeast, southwest to the southeast of the country, and we haven't actually looked into that, and I think it's be very important, and it's obviously a change in weather patterns, and to see why this is happening, because that will inform our models as well. So it is really useful to look into this. So hopefully we'll do these studies in the future as well.
Okay, and the July figures there was a 28% increase. Why is that? Again, is it maybe something that you haven't looked at yet, but it really stood out as a real outlier in your data set?
Yeah, and actually, it's not something we actually expected, but when we looked at it, and we've some of those years you can see that rainfall is very variable, and some years are drier than others. One thing about rainfall is in the summertime, it's not that high. If you look at the figures,
Yeah,
so a small increase makes a big difference,
yeah,
and it's the second lowest. But like we did see big increases across the country, which well, me doing it at the time, I didn't actually expect it to be as big as it was. So it's something else that, we do really need to look into more, because overall, when you look at it, it's to get drier. But as the summers go on with that increase in temperature, but like we didn't see that. But at the same time, for every degree increase in temperature, you expect to see a 7% increase in rainfall. Now, obviously, it is higher, and we saw it across the country, so we do need to look into that. But it's
okay,
once again looking at the patterns, and we've had some summers where if the jet stream in the summertime, if the jet stream stays to the north of us, um, we get nice warm summers. But if it's to the south of us, we get those wet summers where the rainfall is just coming in across. So like last year, we didn't get a great summer, but on the continent they had heat waves and they were suffering with droughts, which we didn't see. But it's due
okay,
to the fact of where the position of the jet stream. So it's something
okay.
that it's really important to look into, I think, in the future.
Okay, okay, that's really interesting actually. So you mentioned a rule of thumb there. For every 1 degree increase in temperature, you can expect rainfall to increase by 7%.
Yeah, yeah, on average, yeah, yeah. So
Okay,
yeah, yeah. So
and is that one of the
that's
outputs from that?
physics, No,
That's just
that's a physical thing, like they
okay,
use it across the world, like you see it.
okay, okay, okay.
Yeah.
I'm going to ask you one final question, and it's probably not related specifically to the study, but when we see the extreme weather events that we've had the last couple of years, so the really bad storms and that, how do we know that's just normal variation versus an impact of climate change?
Yeah, well, we do expect, I didn't mention in this study because I was talking more about the rainfall, what we've seen, but when we do model, we see that extreme events will get more intense and more
Yes.
frequent. And we do attribution studies where we use the models and we look at it. And when we do the attribution study, we actually see that the events have got much more likely due to climate change. And
Okay.
we can attribute it as how much it is due to the change in
Okay.
climate.
Okay. So there's science
Yeah,
behind
yeah,
it, the
there is, yeah.
attribution. Okay. All right. Mary, thanks very much. That's been really, really interesting. Thank you very much.
Okay, thank you.